Hey guys, good evening. I hope I'm pretty much audible. Great. So I welcome you all in today's discussion, which is again into data analysis in 3 weeks. We are winding up our discussion on data analysis. So we are pretty much into our almost the last topics of pandas. So pandas, as you know, is one of the very interesting library available for data analysis, which is helping you to get to do your day-to-day data analysis job to the best of the knowledge, right? So this is again very important library, and it's I would say most of the data science work is predominantly being done on I would say pandas. Okay, so pandas become your one of the really important libraries in that per se. So we'll have to really look into the pandas functions, and in today's topic we'll be talking about pandas function in detail. So we'll be going a bit more detailed into available pandas functions which we have. Okay, so that's pretty much our agenda for the day. But anyway, if anybody is having any concerns, any questions, because yesterday we did some questions, right? So I hope you people are able to connect with those questions. That is again which is very important. So do not sit idle. That is the reason why I took practice questions yesterday, and that should give you a flavor of what kind of things which you can expect in the problems, right? But those were very simple problems. But again, we were getting many very minimalistic responses. So I believe people are still confused, and you might are not trying, or you are still not very sure of what to apply and all that, right? So guys, please feel free to ask me questions if you're not able to understand anything from the concepts perspective. It is really very important to cover up these points. Okay. Apart from watching the videos, always figure out time to at least solve the problems as well, right? So hands-on is very important in data science, right? So in Python, that's what that too in Python, it's very important. So we need to cover up these things. Great, that's fine. But anyway, so today's discussion is pretty much into pandas function. So we'll be talking about some good pandas function, which is pretty much decent enough to know, and they are important ones. But before starting, I'll introduce myself as always. You know, my name is Arpit Jain, and I'm a lead data scientist myself. I have almost 9 years of industry experience into multiple domains. That includes automobile manufacturing, cloud, banking, telecommunications. So multiple areas I've worked with. So if you have any concerns regarding data science as a field or domain, so please feel free to ping me, and then we can always talk there. Okay. Along with this, I'm also a motivational speaker. So I talk to students regarding their job, career placements. So any questions regarding placements, jobs, or what career to choose, career counseling, guys. So do it's pretty much a live session. So we are sitting live here. So if you have any concerns, I'm pretty much monitoring the chat. So you can always type up your things, and we can always talk. Okay. So please utilize the time. So it's pretty much a live session. Okay. Great. So by doing this, I'm moving to the content, right? So content, which is today's discussion, will be on pandas functions. So let me just quickly pull up that. Just give me a minute. Right. So cool. So I believe my screen should be visible to you guys. So now in today's discussion, we'll be talking about few of the pandas functions. Okay. So we'll see what all different pandas functions are there, and what all different arguments which we can pass, and how we can look into these. So that's gonna be our agenda. Hey Mahesh, thank you so much for joining us. Great. So the very first function in pandas which we'll be looking today is transpose, represented by T. Okay, so T is again more of a function, more of a transpose. So what does a transpose mean in general? So transpose means we are now kind of converting the rows into columns and columns into rows. Okay, so for example, now look at this same data. Okay, so I am printing this data frame. So where I have name, age, and height of almost say 7 people: Storm, Jerry, Spike, Popoy, Olive, Pluto, Mickey. So I have kind of 7 people, and then I have their respective ages and height, and that's what pretty much my data frame says, right? Now, the very first function which I have here is talking about my transpose, right? So what does a transpose mean? In this case, what I'm doing is I'm converting this columns into rows, which is name, age, and height, and then I'm converting the rows, which is 0, 1, 2, 3, 4, 5, 6, and everything, into columns. Okay, that's pretty much what my function will be doing, this t. Okay, now look at this, and how I'm going to call this, because again, look at this, guys. T is an object here. Okay, so t is an object of data frame. It's one of the objects of data frame. And how you can find this? You can say suppose df dot and then put a tab. Okay, so you'll get a list of all the available functions, or so all the available objects of data frame which you can run. Okay, so like access, backfill, box plot, copy, core. So these are the functions of or more of objects of my data frames. Okay, like for example t, right? I was talking about t, so t should be here. You can see this. This is my t, so I'm just going to call this t. So t is again one of the functions which is directly available for data frame. And how I'm going to call this? As an object element. Okay, if I run it df.t, now you can see this, the difference. You have the 0, 1, 2. So these are my row indexes, right? So row indexes are nothing but now are my column headers, right? And how can I get the column headers name? So for that I have to do df.columns. Okay, there's a function df.columns. If I do it, I'll get it my so the name of this df name, age, and height. I can obviously save this into say df underscore t. So that's gonna be my this data frame. Now if I do df underscore t dot columns, now array, my bad. I have to do it like this. Now can you see this? I have the number starting from 0 to 7, which is again an iterate per object. Step size is 1, so it's a range index kind of a thing. So it's not a default. It's a default name which I've done, right? Hey Vasanta, good evening. Thank you so much for joining us. Cool. So that's pretty much the transpose does. So we are now converting the row indexes into my column indexes, right? So that's pretty much what we're doing at df transpose t. So now this is my column index, my column headers basically, and the row indexes will become name, age, and height. Okay, so now just transpose the data frame. Again, don't ask me like why do we do this, is it really necessary to do this? So it depends on what analysis you're doing, right? So these are all the available options you have. So whatever function I'll be showing you today, those are the available options. So depending on your requirement, depending on your work, you choose one or the other depending on your requirement, right? So that's pretty much how the usage of it differs from use case to use case, right? The second interesting function which we have in data frames is access. Okay, so this, what it does, it returns the list of data with the rows and the column access variables. So what do I have here? So df is my name, age, and height, right? My column and the rows are 0, 1, 2, 3, 4, 5, 6. So now in the access, what is access basically? So access is nothing but my rows and columns, right? So those are the access of my data frame, right? So basically access means x and the y kind of a thing, right? So here the access are rows and columns. So if I call access on top of my data frame, it's going to return a list with the row and the column access variables. So now can you see this? So the very first thing will be row. So here this would be a row element, which is again a range index starting from 0 to 7, where the step is 1. So I have 0 plus 1 plus 1. So 0 plus 1, 1. Then 1 plus 1, 2. So that's going to be till 7. So that's going to be the part for me, the range index. So start is 0. Stop is 7 and step is 1. Okay, so that's basically my row variables right now. And what is my column variables? That's going to be name, age, and height, right? So pretty much given there. So that's what my access returns. It's a list of my available rows and column variables. Okay, cool. The third again interesting function is endim. Okay, so endim is number of access. So number of access, definitely here. You have one, so you have how many dimensions here? 2. So you have a row access and the column access. So by default, for a 2D data frame here, it's going to be 2 number of dimensions. Okay, it's plain simple. Now, what about the D types? D types again is a very important functions. Okay, and it's one of the, I would say, very major steps, one of the very primary step which you do as soon as you load up your data, right? So now what happens generally? So suppose if we have say 20 columns, 20 features in your data set, right? So 20 columns in your spreadsheet. Now as soon as you load up that spreadsheet in your data frame as a pandas data frame, right? So what happens is, suppose you have a date column, for example. You have a date column in the data, right? In the spreadsheet, what generally happens, this date column is not being recognized as a date column, it gets recognized as a string column. So the date is actually getting recognized as a string, as a text, so which is wrong. It has to be a date type, right? So there is a separately date type as a type of my data frame data. Okay, so this is very important. Now can you see this? So here I have three data sets, three columns: name, age, and height. So name is basically an object, nothing but my string, and age is identified as int64, and height is identified as float64. The reason to that is I have the decimal points value, right? So this is the default a kind of the objects, the data types which has been identified for each of my variables. There could be scenario, potentially there could be scenario where the data types of the actual variables are not identified correctly. So as I said, like for example, suppose this age, if this might have been identified as an object element, so this is incorrect, right? So I mean it's again a Python interpreter which is interpreting your data type. It's like kind of interpreting it by default. And what if this interpretation is incorrect? So we obviously, the very first step as soon as we load up the data is check the data types. So I mean the way the data has been loaded up, whether the Python interpreter was able to identify that data type or not, or if the Python is unable to identify or has identified it incorrectly, then in that sense you have to manually correct that, right? So that's what this data types is needed for. So this is again one of the very important steps of data analysis. Cool. And I'll show it to you how to change the data type also, so don't worry about that. I'll show that to you. Okay. So now I have another very interesting function which is shape. So shape is also very important. Okay. The reason is you actually, whenever you're doing the data analysis, right, there is a high probability that you do on running data.shape like almost after every whatever checks you perform, right? So you end up doing this almost after every code performance. The reason to that is it gives you the dimension of the number of rows and number of columns. So basically, suppose if your original spreadsheet has say 10,000 rows and 20 columns, for example, right? So here the shape is 10,000 cross 20. So that's exactly what my shape would be returning. So here it's a tuple element where the first element is the number of rows and the second element is number of columns. So 7 comma 3. So here 7 comma 3 is what basically my number of rows and number of columns. So in that sense, if I have a spreadsheet which has 10,000 rows and 20 columns, so here the output would be 1000 comma 20, right? Now suppose you performed a kind of a join on another table, okay? And then you want to check after joining how many rows and how many columns got updated. So updated data frame, on that updated data frame, what is the number of rows and columns, right? So you always, generally you always keep on checking the data frame shape after each and every analytical step you perform in data science. So that's something, just again this function comes very handy in that. Okay, so we can also use, so it's pretty much kind of sliceable. So for example here, if you do 0, so it's like a tuple, right? So tuple and list, so you know how to access a list element. So I have, so if I write, so what is the length of this? So if I just simply type a length of this, I'll get what? 2, because I have 2 elements here, right? So I can simply access them one by one, right? So how can I access them? By giving the indexes. So for example, if I give 0, I'll get the first element, which is nothing but my row. So by default, df.shape of 0 is nothing but my row element, right? And then df.shape dot 1, that will be my column element, isn't it? So I can also find out how many rows and how many columns by just doing this. So if I do df.shape0, I'll get the number of rows, and df.shape1, I'll get number of columns. Okay, so that's pretty much what my df.shape does. Okay, so we have a question from Mahesh. He is asking difference between dimension, okay, ndim and head-shape. That's a very good question. Okay, so see, dimension is nothing but giving me the axis, number of axes. So here the number of axes is by default 2, right? So you have 2 axes, you have rows and columns, right? Because it's a 2D data frame. So you have number of dimension will be 2. But again, in this in this individual dimensions, for example, rows. So now you go more deep in this. So for individual such accesses, how many elements are there? So that's what we get it from shape. So here, so shape is giving me the number of rows and number of columns. So now, although I have 2 axes, which is rows and columns, now internal to this axis is how many elements are there per axis. So that's what shape gives me. Okay. Great. So again, I've just used the same thing by just in a simple print format also. So just look at this printing statement. This is again a very interesting way of writing the print statement also. So suppose you want to kind of do a dynamic kind of printing. So for example, you want to print my data frame has these many rows and these many columns, right? And you want these rows and columns to be dynamically printed every time whenever you call this. So whatever data frame you pass on top of this, right? So this should be valid. So you're not manually printing the exact number of rows and number of columns, right? So you want whatever data frame I pass, from that data frame it has to be, it should pick that, right? So that's what I want. So to use the dynamic numbers from the data frame, we use a curly braces format. Okay, so we use a curly braces inside what. So for the numbers which I want to be dynamically updated, right? So whatever value I want to be dynamically updated in the print statement, I use curly braces. So now in this curly braces, what I want to fill, that I can give using the dot format. Okay, so just look at this. I'll just explain you what it is. So I use after the quotations, I write dot format. Okay, within the print parenthesis only. So it's still within the print parenthesis. Okay, same here. But after the quotations closer. So my quotation is getting closed here, right? Quotes. Now in this, I do write dot format. So in this dot format, what I write, so I have two braces here, right? So this is my first braces and this is my second braces. So in this, again I have to write for both the ones what I want to fill. So for the first one, as I said, number of rows, right? What is my number of rows? Same thing, df dot shape 0. This is going to be my number of rows, right? Now again I have to give a comma because I have two elements to be provided here. The second element will be this. What is this? Number of columns. And this is my number of columns, isn't it? So I'll just write it here. So now what will happen? This curly braces will be replaced by this value, and this curly braces second one will be replaced by the second value of my dot format function. Okay. So now you can see this. The print statement will get my data frame has 7 rows and 3 columns. And 7 is nothing but my row element which I'm passing as my first argument of my format statement. Okay. Again, an interesting way to write the print statement. Okay. So just keep a note of that as well. Cool. So now we have two important functions, which is head and tail. Okay. So these are two interesting functions, head and tail. So what does a head do? So now, for example, just remember, just assume that you have a very big data frame. Okay. So you have, again, as I said, 10,000. So it's not still a very big, but a big data frame. So 10,000 rows and 20 columns, right? Right now, if you see this, so if I just print df, for example, here. So if I do df, so what I'm looking at this is, I'm seeing name, age, height, and all the elements which is part of my data frame pretty much printed here, right? So there are 6 elements, there are 7 rows and only 3 columns. Then I'm able to see the data frame very clearly, right? So it's only 7 rows I have, right? So all the 7 rows are pretty much getting printed very easily, and I'm able to see that. I'm able to visually look at the data. But what if my data frame is more? So the number of rows are more, maybe 1,000 or 10,000 or 1 lakh, right? I cannot simply look at the entire data here, right? At the same time, if I do print df, so I mean, it's impossible to look at the entire data just visually seeing all the elements, right? It's not possible. So for that reason, I have two functions here, head and tail. Okay. So both head and tail, they take an argument n. Okay. Even I can also skip this. So I'll tell you now. Inside this, you will figure out what exactly the arguments are. Okay. So now can you see this? I have an argument called as n. Okay. And can you see the default value is given as int is equal to 5. Can you see this? So it is an int element. It will always expect an int element, and the value here is by default 5. So if I won't specify the n value, it will by default take 5, right? And the same thing is valid for tail also. So if I won't give any number, it will take by default 5. So if I give df.head, it means that from the top, it will filter out the top 5 rows for me. So top all the available rows, it will try to filter out the top 5 rows for me in the data frame. So if I do df.head here, can you see this? I'm only seeing the top 5 rows. I'm not seeing the entire all 7 rows. I'm just seeing the top 5 rows. So till the index 4, which is olive, right? So I'm only able to see my data till olive. And anything, so beyond Olive, I have Bluto and Mickey, so those are not getting printed. Cool. So that's what head does. And also, as I said, head takes an argument n. Default is 5, that is fine. But I can also specify n. So whatever if I give head is 2, right? I'll get only the 2 records. What if I give 3, right? I'll get 3 records, right? So now a quick question to you guys. A quick question. What if I give here, say, 10? What will happen if I give the value df dot head 10 here? So although I only have 7 rows, right? So there are no 10 records in this. There are only 7 records, but I'm passing df dot head as 10. Can somebody tell me what will happen? What should ideally happen here? If I pass the argument as 10 instead of 7, which is max here, what will happen? Quickly, guys. Okay, Mahesh has an answer 8 onwards nan. That's a very good try. I really like the response, Mahesh. Thank you so much for responding. We'll look at this. Okay, and then we have another response from Hellfire, and again we have the same thing here, till 7 and then nan, right? So okay, I'll take this again, the same thing. Akash says till the data is present will be executed. Okay, so basically it will only execute till the data is present. Okay. Okay, Vasanta says it will create null values. Okay, let me. Also, so basically, 3 people are saying it will create the null values nan for wherever the indexes are not present, and Akash only says it'll execute till the data is present and nothing beyond that. So now look at this. Look at this. To your surprise, it will not execute anything. So Akash is very well right here. So it will not execute anything beyond the maximum number I have. So but it's a very good try, guys. So when you mentioned null and nan, so I'm pretty much assuming that. So while we were doing the other things in data frame, where we're doing the indexing of my new column, and that column was not existing, so it was adding nan, right? So I'm pretty sure you kind of understood that part. Okay, so you kind of try to relate that. I'm really happy that you remember that and you try to relate it. But unfortunately, that is not. It's not same here in head. Okay. So it will, even if you pass the maximum number, even if you give 100, right? So that still is going to return you only till the number the data is existing. Okay, so till 7 and nothing beyond that. It won't do anything. Okay, so this is again one of the tricky questions. These are one of the tricky questions which are generally asked in the interviews. Okay, so that is the reason why I try to cover these tricky questions also at the time of teaching itself. Okay, so yeah. So as I said, it's pretty much it will only execute till the data is present and nothing beyond that. Okay. The same thing is pretty much valid with tail, but in this case, as the name is pretty much clear, so now df.head is nothing but starting from top, the in ascending order, the indexes in ascending order, right? But in tail, it's going to take the indexes in descending order. So now here, starting from this, so the last index, the last 5, so 6 5 4 3 2, so starting from 2, so last 5 index till my last one, that's what that will be printed. So last 5 records will get printed in df_tail by default if I won't specify n. But what if I specify again the same thing? For example, if I specify 2, so I'll get the last 2 record, which is Bluto and Mickey. So 5 and 6, the last 2 indexes. And I can also specify any number I want. I can specify 3, I can specify 4. So pretty much the same thing. Okay. Any doubts here, guys? Any concerns? Anything? How to see default parameters in Colab? It's a good question. So as I said, so just move your cursor. So this cursor inside your parenthesis. So I have a function df.tail, right? So under this, just move your cursor inside the parenthesis and press Shift and Tab. Okay, Shift and Tab together. So if you press Shift and Tab, this is going to open up this dialog box. So like a doc, it's a small doc which is attached to this function. Okay, and you can see a small plus here. So just click on this plus. You will see the document associated with this function. Okay, and you can see I have pretty much the n here, and what is the meaning of n, it is also specified, and how it also tries to give you a few of the examples also. Okay, it's very handy. I mean, yeah. Again, guys, so it's I mean, some few of the functions are very common, so we'll definitely remember that as you keep on practicing it. There are many high probability that you might miss out on the few functions. Yeah, it's not, we are all humans, right? So it's okay to not remember every other function. Trust me on that. It's not an exam. It's okay to forget few functions, but again, you should be smart enough that if you have forgotten that function, then how to work on that. So you can obviously quickly look into this shift tab and look at the arguments, so how to pass the arguments, what does it expect, right? So pretty much be a smart employee, right? Cool. Great. Moving ahead, again, we have a very good function called as empty. Okay, so df.empty. So what it does, it will always check whether my data frame is empty or not. Okay, it will check whether the data frame is empty or not. So here, it will return the boolean, which is true and false. So if my data frame is empty, which is in this case not, so I have the data frame, I have the data here, right? So I have 7 rows and 3 columns. It's not empty. So if I pass df.empty, it should actually return false because the data frame is not empty. Okay. Again, this is very interesting. So this is very interesting in terms of I would say your so again, you can ask me why, when and why do we use this. So because you can obviously ask me, right? So I know I have created this data frame, so I know this, it won't be empty. So why somebody would create like this? So the reason to that is, again, assume that it's a big code, right? So it's like 1,000 lines code, and in between some code you're creating a data frame after doing some analysis, after doing some manipulation in the code, right? And what if say this code does not get executed with some wrong data being fed, and this data frame does not get created, and ultimately you had some other dependent functions on top of this newly created data frame. So you can always write a try and a catch, right? You can always write an error handling, right? So what if the data is empty? To not run the code, maybe pass an error message like a print statement or a logger, or you add the log message in the logger, right? So you always have a condition, a check in between the code itself, that if the data frame is empty, do not do anything. Otherwise, it'll give you an error, and the compiler will give you an error. So it will eventually, the code running will get stopped, right? So the code will not get further executed. Cool. Okay, Mahesh says collab, it's not working, shift plus tab. Okay, I need to check that on collab. So I myself generally don't use collab. Let me check this and come back to you. Maybe you can quickly just do a Google, Mahesh. Even I don't know, so I generally don't use collab. So maybe it depends on the different platforms. So just do a Google search, and you can try to find out how to see the documentation of functions like shift tab in notebook. So how can I do that on collab? Okay, you will definitely get an answer. Okay, cool. So great. Let me give you some descriptive stats. Okay, this is again very interesting. Okay, so I have few of the very interesting. I'll come to describe later. So describe is again very important. So, but again, before this, I have some really interesting descriptive stats functions. Okay, so what are my descriptive stats here? So descriptive stats like sum, mean, mode, standard deviation, minimum, maximum, absolute, prod. So all of these are descriptive stats, right? So all of these are some of the other functions, some of the other descriptive stats which we might need in our analysis, right? So for example, I have this data frame. So run this data frame here. So I have this data frame. So I have name, age, and height, right? So what if I want the sum of all of my ages? What if I want the sum of all my heights, right? Something like that, right? So pretty much I can do that. So now how to run sum, right? So for example, this. So sum here returns sum on by default axis 0, right? So for example, I'll show it to you. What does it mean? So I have df and I want the sum of age, right? So I have to pass df of age, and then I have to pass sum like this. Okay, so then I'll get 142, right? So I'll get the sum as 142. So basically it is giving me the addition of all of my ages, right? Now in this sum itself, we'll open the kind of thing, a documentation, and you can see this. So we can also specify the access and also specify the skip NA. So this is again two important things which you should look out. So skip NA means if there is a missing value in the data frame, right? So ideally it should not give you an error. So if we have an NA, if we try to add some value to NA, right, it will give you a compiler error. So it will give you a value error, right? So we can always skip that error by specifying skip NA is equal to true. If you're gonna do skip NA is equal to true, it's gonna skip the missing values, okay, and it won't give you an error. It will just keep on calculating it, okay. So now what if I specify here dot sum, and if I give 1, okay. So now look at this, what's happening here. Just look at this. So now here I'm specifying as 1. So I'm specifying the access is equal to 1. That means that instead of doing the column wise addition, that means that all the row values gets added. I don't want like this. I want this age and this height to get added. I want this 12 and this 1.11 to get added, right? So for that reason I can specify access as 1. So I don't want the addition to happening row wise. I wanted it column wise, right? I can still do that. So pretty much fine. So now 10 plus 3.25 will return 13.25, right? So I'll be having how many indexes? So I have 7 rows. So output will also have 7 rows. Okay, so 7 values. So likewise, it's pretty much doing the printing statement here for if I give df of sum of 1. So that means that sum on the column wise. Okay. Same thing. I can pretty much do the mean. So we've already seen this in one of the examples yesterday, right? So how to get the mean. And how to get the mean, it's an object element. So we can specify the mean here. Again, the same thing, df dot age, for example, and I can call this mean here like a dot mean, and I'll get the mean of my age, right? So I'll get the mean of my age. Pretty simple like that. Likewise, I can also get the mode. So mode, again, dot mode and dot standard deviation. I can also get the standard deviation. I can likewise get the minimum, the maximum, and the absolute, and the prod. So everything is an object of my data frame element here. So on whatever column you want to specify, you want to calculate these descriptive statistics, you can pretty much call the individual function and get the values straight away. Okay, very simple. There's nothing very fancy in this. It's pretty simple. Cool. Now, since again you can see this is very interesting, very important. So sum, mean, max, minimum, standard deviation, absolute. So these are some of the very commonly used descriptive stats, and these are some of the important descriptive stats, right? So we oftenly need them, right? So we also have a very good function available, and very handy function for your data analysis called as describe. Okay, so describe is one of the very important functions available in data analysis. So as I said, one of your primary steps to as soon as you load up the data is check your data types, right? So that's I would say the step 1, like check the data types, right? This likewise dot describe is your step 2 majorly. So right, so we always tend to perform data df dot describe and try to look at the basic health check of my data, like, and in describe I'll show it to you how good this is. It's pretty much equally good for a categorical column or a numerical column. So we can see the description of describe of my all the available features I have. It's pretty much possible. I'll show it to you. Okay, so now here, suppose now look at this data frame. I've created a new data frame, so I'll just print this for you first. So this is how my new data frame looks like. So I have 4 columns: ONE, TWO, THREE, and FOUR, and then I have the 5th column, FIVE. So these are my 5 columns. So 1, 2, 3, 4 has 4 individual rows. These all are my numbers. But my last column, which is 5 FIVE, I have 4 different elements, which is a string. So A, B, C, and D are my 4 sub elements there, right? Now, first of all, I'll show it to you what all different arguments it take. Okay, so for example, here in describe, if I have to look at the arguments, now look at the arguments here. So I have percentiles, I have include, I have exclude, and date time is numeric. Okay, so these are the 4 arguments I have. So I'll simply talk about the things which is being given here. So let's talk about them one by one. So first I will show you the results, then I'll talk about the functions here. So if I run df.describe, now look at this. So the important thing to notice, there are a lot of numbers here, right? So it's, again, look at this again, always remember guys, so like the way while we are plotting the graph, our job does not stop just at running the graph. Okay, now our job as a data scientist in fact starts from there, right? Now what, how will I read the graph? Like the same thing here in descriptive stat itself, there's nothing fancy in running this code. It's just like one line of code. You have to describe. You're not doing anything fancy here, right? Now, once you have this hell lot of numbers available here, right? Now, how will you read it? How will you get a business inference from this? That is what your, I would say, the thing is, right? So you have to always understand how to read these numbers, right? So, for example, here in df.describe. Now, can you notice one thing? I had 5 columns, 1, 2, 3, 4, 5, but in the describe, I'm only seeing 1, 2, 3, and 4 here, right? Can you see this? I'm only seeing 1, 2, 3, and 4. So I'm not seeing this 5th column here. I'm only seeing the 4 columns, okay? And what are my attributes here? I'm getting the count, I'm getting the mean, standard deviation, minimum, 25th percentile, 50th percentile, and the 75th percentile value, and also the maximum value, okay? So these are some handy numbers which is directly available as soon as I run the describe function, okay? And also, since you have noticed that my column 5 FIVE is not by default available here, right? So I'm more of trying to understand what exactly this is. So by default, if I simply run df.describe, this is what I'll get, okay? I'll always get the numerical data only, okay? I'll only get the numerical data if I do not specify what arguments I want, what data I want, what do I include, what do I exclude, okay? By default, I'll only get the numerical data, and for those, I'll be getting the count, the mean, the standard deviation, and all of that point, okay? But now, so in first, I'll show you what can I edit here, okay? So now, for example, I'll just go back later. So the very first argument which I was having was percentiles, isn't it? So now in this percentiles, so by default, we have 3 percentile value, 25th percentile, 50th percentile, and 75th percentile. I can always edit this, okay? So now I don't want to see 25th and 50th percentile. I can just do, I want to see 75th percentile, 80th, 85, 90, 95, and 99. So this is the a new modified version of percentiles I want to see. So I can simply pass the list of percentiles value which I want to be seen in the describe function as a list for my argument percentile, okay? Now if I run it like this, can you see the output, which is pretty much changed here? So now, instead of having all of the remaining others, I only have the values which I've passed. So 50, 75, 80, 85, 90, 95, and 99, okay? So can you see this? So this is the percentile values I can also edit just by passing in the describe function. And obviously by default, this percentile is only existing for my numbers. The percentile is invalid for my strings, right? So how can I get a percentile of a string? And that's pretty much genuine by default understood, isn't it? So this is valid for my numerical kind of a data. But again, as you know, we also have one categorical data, which is FIVE, which is a string, right? So how to get the descriptive stats of my categorical data? So for that, we have 2 different things which we can perform, okay? So I'll just show it to you quickly. So I have something called as exclude, and I have something called as include, isn't it? So in the exclude, so suppose I only, so likewise when I'm seeing here only the numbers, right, in my as my descriptive stats, now I only want to see the categorical data, only want to see the strings. I don't want to see the numbers. So in this case, I can simply pass exclude number, okay? So if I exclude the number, in this sense, I'll be only getting the descriptive stats of the column 5, which is a string for me, right? So for this string, can you see this? Earlier, by default, I was having these many individual parameters, right? So count, mean, standard deviation, minimum, maximum, 25th, 50th, and 75th percentile. But can you have a minimum? Can you have a percentile value? Can you have a standard deviation on a string? You cannot do that. You cannot calculate a standard deviation on a string, right? So likewise, the descriptive stats of a categorical variable is different, okay? So here the parameters are again the count, the number of unique values, the top value and the frequency, right? So which is the most occurring value, which is top, and the number of that occurred top value. Okay, so this is what it shows by default, describe for the categorical data. Okay, so this is how we can find out the kind of description for my numerical as well as the categorical data. But we can also do include is equal to all. Okay, so we can also do include is equal to all. So in this sense, what we will find, we'll get all the available data types which we have. So now if we run it, now can you see this? I have 1, 2, 3 and 4, and I also have the 5 column here. But now look at the data, look at the descriptive stats. So now in this parameters, you'll find out all the parameters for both my numerical as well as the categorical data. All the parameters will be available here, okay? But as for the obvious reasons, so top and frequency are unique. These are only valid for my, this you can still have the top and the frequency, but here it is by the code logics, it will only get executed for my categorical data, and for the numerical data, these values will get executed from mean till maximum, right? So anything apart from this will be nan. So I cannot calculate 1, 2, 3 and 4 for these columns, unique, top and frequency, because by default in the code logic it's only for categorical data. So it'll give you nan value here, and likewise I cannot have the standard deviation and minimum and all that for my the categorical data. So that's why everything here will be nan. Okay, so that's pretty much what describe does. Okay, cool. So quickly guys, anybody is having any questions, any concerns from whatsoever we have discussed so far? Any questions from anyone? Mahesh, Vasanta, Akash, Hellfire, you guys are able to understand this? So this is again, since we are into data analysis, right? So that is the reason why we are trying to cover these important topics. So guys, if you're very comfortable, trust me, I'm gonna ask you questions on describe and other things, whatever we have learned today, okay? And I'll be asking you to solve those questions tomorrow. So tomorrow we'll be having again the questions round, okay? So I'll be pretty much covering a basic topic, and then I'll move to the questions again. So I would really expect you to solve those questions, okay? I would really want you to solve those questions. So again guys, I'm still asking, if anybody is having any doubt, anything in whatsoever we have discussed, please do let me know. And are you guys solving the questions at home? So did you try solving the questions which we did yesterday in yesterday's class? So I think in yesterday only Mahesh was responding. What about others? So you guys were not available yesterday? Hellfire, Akash, Vasanta, you guys were not there yesterday. So I mean, or did you have you seen the questions which we solved? Is it clear to you guys? Okay, great. So that's pretty much fine. Great then. So I think that's pretty much it. So let's wrap up for the day. So now what we can do is, so tomorrow we're gonna meet at the same time 10 p.m. But tomorrow's objective will be to quickly cover the left out topics. So I mean, pandas is pretty much equally good in strings also. Okay, so I'll just quickly cover a few of the string functions tomorrow, and then we'll try to solve again few good questions. Okay, so we have, I think, we'll take 3 to 4 more classes in pandas. So today is Wednesday, so Thursday, Friday, Saturday and Sunday. So within 4 days we'll try to finish pandas. Okay, so that's pretty much what we'll be doing tomorrow. Great guys, thank you so much. So see you tomorrow, same time at 10 p.m.